So, dear friends, coming to look at the C++ classes and functions, we come to a point where we want to note certain functions called friend functions and some static functions. So, first of all, I'd like you to see the code. So, as usual, hashing2.str.h iostream, sorry, not str.h iostream, using namespace std, defining the namespace in which the functions as well as the various objects are going to be declared and accessed. And then now for the time being, I think you can see in the comment the static int y. I'll explain all of that in a bit. So we shall not be paying too much attention to the static int y right at this moment. But we carry on to the next bit, int1. As you can imagine, this int1, now this is obviously a private variable because it's got no qualifier, and hence its default, and that would be private. The next one, int2, is a protected variable. Now, as you know, that int1 should not be accessible outside of call main, which is the class, which is this class here, and protected into this one can be accessed outside the class, but only in those which are inherited from it, that is the subclasses, not beyond that. Now we have the public domain. Here we are declaring as public call main, which is, by the way, a constructor, as you can imagine. And then we have the set1 2, which sets the two integers int1 and int2. Now we have something peculiar. We are trying to print out 1 and 2 here, and you can imagine that we'll be printing int1 value, one copy of int2 value in this. Just look at the declaration of it. We started with friend, then void, and then print cm12, and we have given the argument or the parameter as call main, which means that we'll include a call main object in it. And then we have a static function. But at this point, I would like to give a gap and explain to you what I'm doing with this friend function. So what is a friend function? Just as we have friend functions, we'll have friend classes. So what is a friend function? See, a friend function is a function that is not a part of the class itself. So print cm12, rather print cmi12, which is short for call main integers 1 and 2, print CMI 1, 2. This print CMI 1, 2 function is not a part of call main proper, but it remains outside. It is declared outside of call main. Many a times it happens that certain variables inside an object which are private or protected may need to be accessed by the outside world for certain reasons. For example, monitoring of values, etc., etc. And these monitoring functions, now, they will not be a part of the object per se. Then those will have to remain outside whilst they will be able to access the private and public, I beg your pardon, public you can obviously access, but private and protected values available within the attributes, that is the variables. To check and monitor, for example, that's an example. To check and monitor, that is just an example. There can be several other uses like this. In this case, we declare this function as a friend function, and we can set or print or whatever the values of the attributes available. But there is one thing that you must note, that these various attributes that we are trying to access through the friend function, those attributes or variables, as you may call them, now they are available only when an object has come into life. That is why we have to pass it an object of the class to which it is a friend, or of which it is a friend. And in this object, whereas otherwise you would not be able to access any of the private or protected variables, in a friend function you would be able to do that. So see, out here, void CMI 1 and 2, and see where the cursor is blinking, that's a void print CMI 1, 2 function. And we have given it, we're passed it a reference to call main object, and of that call main object that we're passing the reference to, the print CMI 1, 2 will print the int 1 and the int 2. Now, see, if you go to the end, you'll see once again the endl. Remember, much better to use this than to use the \n, because this also clears the buffer. Let's see the uses of this. In int main, we have not come to the static bit yet, so we're just explaining the friend function. I have called one CM1 with default constructor. Now once again, just to repeat, you see the constructor is written as this: int I equals to 90 and int j equals to 110. So that means that if you're passing it some values, your values will be taken into I and j. If you're not passing any values, then I and j will assume the default values of 90 and 110 respectively, and this will be assigned to int1 and int2. Now I've also used another object called, or another bit called this, which I'm not going to as such mention now. I'll be doing that in just a minute. But those are the code. This arrow int1 equals to 1, int2 equals to j. Now you see this arrow is the same as the arrow you experience in C, which is basically using a pointer to access inside the structure. In this case, a class. Well, it's a structure object or a class object. In this case, it's a class object. And look at the so here also we set 1 2. That means we set what is the set int1 set int2. I mean sorry, set 1 2 gets an int1 and int2. Now we have this. So here you can imagine what this is all about. THI is this arrow. This is basically a class pointer of the type call main, referring to this particular class's object, the object that you are creating, that object. Now you see what we have done here. We have passed int1 and we have passed int2. Now sometimes we need to pass variables by conventional names which cannot be changed, but then in that case here it would be a problem, because you see we are passing two integers int1 and int2 which are local copies of set 1 2. That means the local variables to set 1 2, but we have also got to use int1 to assign the newly passed value to this int1. This int1 is basically belonging to call main, and this int2 which belongs to once again call main object. But there will be a problem, as you can imagine. If I removed this from here, the self-referential pointer, ran it, see this makes it clear. Now in many compilers, rather than if you don't use this, it create a confusion, because which int1 is which. This is this int1, this is this int1. Now is the int1 on the left hand side. If you don't have this here, if we didn't have this, then these two int1s would produce some ambiguity, because is it the int1 that is declared here, or is it the int1 that is declared in the class, which is out here, there, this one. So is it this one, or is it this one here, belonging to the method that you're using? Hence, to avoid this ambiguity, we have this facility, this. Okay. And this is especially useful when variables that are passed have got the same, or variables that are used to pass values to functions. Okay, these are the parameters. These are the parameters, and the actual values that come in are called the arguments. So wherever there is a point where the parameters are basically clashing with the arguments in name, we use this. This means this object and not the one in the method, not the one declared in the parameter, but this is the object or variable or whatever of the same name that is used in this particular object, in this case the call main object. Now you see in this constructor here we are using I and j. Obviously it's a default cum parameterized constructor, hybrid constructor. Here we've used this int1 equals to I, and I've also commented here, you see, no need for this, because this I is differently named to int1. So if int1 equals to I is there, the compiler immediately knows the left hand side belongs to call main and I belongs to the left hand side belongs to an object of the call main. It's a class variable, and this one here is a method variable. This is the parameter. There is no, absolutely none whatsoever ambiguity, and that's exactly why there's no need for this. You see, int2 that is also there. Remember, in this case, when I put in this, I removed the this. It actually worked. So mobile compilers tend to be a bit more advanced. So it resolved which is which, probably. But in box standard compilers, you have to use this if you're using the same names in the parameter lists as well as the class. Now, here is our friend function. We're printing int1 and int2, and you see, in every case when it's a method, that method, what is the method? Method is a function declared as a member of a class. Whenever we're using methods, we're saying the name of the class, the scope resolution, and then this name of the class, the resolution, it's like it belongs to, sort of, this main. Now, in this case here, you see, being a friend function, there is no mention of the class name when we are declaring, rather defining the function. There's no class name. That's because it's a friend function. It is supposed to remain outside the class but work inside the class, even with, because it's a friend, even with the private and protected variables of the class, not just the public ones. The public ones can actually be accessed by the member of operator, dot operator. So now with this entire program in there, see what I've done. In the int main, say I've called call main, it's pretty easy for you to understand. Object cm1 of call main, the default. So if it's just called here and nothing else is happening, that means we have given it, we have called the default constructor, which becomes 90 and 110. Well, int1 becomes 90 and the other one becomes 110. And look at cm2, we're passing it the values 12 and 13. Now look at another, we are printing it. So we are printing it by the use of the function print cmi12, which we just did, the friend functions. Print cmi1 to cm1, and then print CMI1 to CM2. It basically be printing the values that have been passed to this. Now I'm using the function where I use this operator, set 1 to 2334. This one here. Now, once that is done, once the printing is done of CM1 and CM2, we so now you see, and I'm calling this now. So you print CM1, and I'm giving set 1 to, which is actually the function that uses this self-referential pointer. So I'm passing it the values 23 and 34, and I'm printing CM1 after that. So passing CM1 the value of 23 and 24. I am just no, printing the values. Now once again, no. Up to here, that's okay. Now the next part obviously seems to be a bit tricky to you, but we'll come to that in a minute. First of all, let's run it and see what happens. There's something. Oh, sorry. So printing mistake there. Sorry about that. Run it. Okay. So look at the first lines. 90, 110. It was just 10, 12, and 13. That was what the compiler, the constructor rather, was called with. And then we have 23 and 24. And then two 30s. We are not going to that now. The 23 and 34. We're going to that. The first one is the first CM1. Second one is CM2. 23 and 34 are CM1 being reset. And so now the int one of CM1 is actually 23. Int 2 is 34. Now let's come to the interesting later bit. Static void set printf CMX. Set and print CMX. Now I have declared a static. Now you see what is static. It has the similar connotations to the static integer that you've seen and used in C. That it basically means an integer that doesn't change. It actually doesn't mean that you cannot give it any values. It is a variable after all, not a constant. But It means that its copy is made only once and remains live throughout the program. And that is why you do not, and in case of C++, the additional thing is that you do not need an object reference to call a static function. Just a class reference is good enough. Object reference means, for example, in case of the objects like cm1, 2, so we were just calling cm1 not set1, 2, 23, 34. In the previous videos also you've seen, and programs, you've seen that the members are actually accessed by dot when it comes to looking at objects. But in this one here, set and print cmx, okay, you do not need it. You can just call it by a class reference to main. The object reference is not needed, except that you can do an object reference. You see here, cm2.set and print cmx, set and print cmx. So this is called on the context of no particular object at all, just a class reference. And this here is the set and print cmx that is called on the object cm2. So that means that obviously if you form an object, if it contains a static method inside it, you'll be able to call it. There's no doubt about that. There's no doubt about that. But if you are not calling it, if you do not want to call it within the, if you don't want to call it in the context of a particular object, because static method is static method, it's created once and available throughout the program. So then you can also do it using this, which is the class reference, call main scope resolution set and print cmx. So you see that from here, you're calling on the class now. Run it. But from the usual stuff, the 230s, remember, we set inside the function, a static function, set and print x. X is a static variable, which is then set to whatever you're setting it to. That's being printed out. So basically, we print it out by adding 15 to it. You see, look at the code once again. There you are. Static int x, that's declared here. And then x equals 15, and then whatever has been passed is going in there. So this one, when we run it, 30, 30. So x is 15, x plus 15 is 30. Now you may say, let's go back to the code. You may say, what is this doing here then? Well, the two things I want to show you. Now, just as we have a static integer inside a method, we can have a static integer in an object also. Which, by the way, doesn't make too much sense. In many cases, because they're dealt with differently. In fact, we're talking about static to the point of view of learning it, but C++ doesn't force you to include everything inside classes. C++ has got constructs which allow you to write a program just like you would a C program. So you could just declare it there. Never mind, but it is there. Now you see when I say static int y and it's set and print cmx, if I do this, so if I run it, there is a compilation error. What is the error? So this is, look at the last 2-3 lines. This, that means this operator, is unavailable for static member functions. This is unavailable for static member functions. This arrow y56 will not work. So as you can imagine, for static functions, okay, this self pointing, the self-referential pointer to the object that we're calling the entire operations on, so that one there. So you see, this will not be available for static methods. As soon as we call off just one sec. So that is why I'll have to scrap yes one sec. Yeah, so basically I just give it now you can just run it there, 30 and 30. And the previous 2 columns have already been discussed. They belong to 3 classes, but now we are between 30 and 30. Okay. Now, once this has been, this was done, let me show you another peculiar thing about C++. You see, just as constructors are called when objects are processed, that they one to the other, it just creates a vision of, okay. So the static void set printf and others. Now, when you are dealing with this, you may have, see, when you are calling this object, it's calling a constructor. So what happens when the object is, when you exit the scope in which the object was created? Obviously, the object will be destroyed. So then we need something called a destructor, and it looks like this: a twiddle, and then the constructor name itself. And although this is not the C++ style, you can still do this. Just to show that you can do this, I am including call main inside here itself. I'll just say that cout and Double quote. Call main let's finish this up as a handle. Yeah. This is only coming to life with, in every field, in every programming language, including C++, destructors are always there. Except that in C++, it allows you to do a certain number of things before the object is destroyed. For example, if you're using up a lot of memory space, freeing up the memory space can be done in the course of a destructor rather, not a destroyer, sorry, destructor. And destructor is it with a class name, it's just a 12. Let's see what happens. Let's see. Call main object, then destroyed, and then destroyed again, then destroyed, and then after that, the call main objects, the destructors were called, so call main object destroyed. So during the final exiting, the CM1 and CM2 finally destroyed. So this is a destructor. So friends, we have covered in this particular video static functions, friend functions, and static functions. Okay, this referential, self-referential pointer, as well as a destructor. So the next video will cover once again some more interesting topics.